Welcome back, everyone. My name is Aaron Hunter, and we have Kyle.
I'm still Kyle.
Still Kyle. Nothing's changed, but we have someone new. Bhushan, how are you today?
Hi, Aaron. I'm good. How are you?
Doing pretty well. For anyone who's new, welcome back to AWS On Air. My name's Aaron Hunter. I'm a senior technical trainer with AWS Training and Certification. My buddy Kyle here is a solutions architect on the TDIR team. What is that, Kyle?
Threat detection and incident response.
And Bhushan is?
Hi, I'm a senior software development engineer working in AWS IoT. I've been working as a software engineer in AWS for over 6 years now.
So what is AWS IoT? And specifically FleetWise? It's more about like machine learning stuff for cars or vehicles?
Yeah, so AWS IoT FleetWise is a new fully managed AWS service that we launched. We went GA this week on Tuesday. And it's a fully managed AWS service that allows automotive customers to collect, transform, and ingest data into AWS in near real time and at scale.
That's really cool. Congrats on your launch. You said it went GA or generally available for everyone who doesn't know what that means on Tuesday. Today's Friday, so 3 days ago.
Yep.
So before the launch, what was the problem that customers are trying to solve that this launch now helps them with?
Yeah, that's a great question, Aaron. So the two major problems that we saw automotive customers had when it comes to data collection and data ingestion. The first problem is dealing with data fragmentation. Every automaker has these heterogeneous fleet of vehicles where the data, the in-vehicle communication standards and formats that the data is collected in is very different. And so they needed a solution to standardize all this data into a standard format so that they can run analytics applications on their entire fleet of vehicles. And an application that runs on one type of vehicle model can work on any other type of vehicle model. And it's just very seamless for them. The second problem that customers in the automotive domain dealt with is this problem of data tsunami. We heard a lot from a lot of customers that they have data from they're constantly collecting data from these different domains of the vehicle. They're collecting speed, they're collecting data from their powertrains, from their ADAS units, from their camera data, but they're not able to make sense out of it, and it's also very expensive to do that. So they needed a more intelligent mechanism to collect this data. And so these are the two main problems that the service solves today.
A lot of data. Sorry, go ahead.
Sorry.
Sorry.
I was very excited hearing about this GA leading up to today. And normally I try to find ways of how technologies can really be impactful to one society, myself, not for selfish reasons. But thinking about this actually came timely this morning. So getting the daughter ready for school, wife's on her way to work, and her rear tire blows up. And it's very common around this time of year in northern Nevada because of the high temperature fluctuations we have. During the day, it could be 80 degrees. At night, it could get down to 40. And guess what? Air doesn't like expanding and contracting over and over again.
Yep.
And I see something like IoT FleetWise being able to help automotive manufacturers, maybe even tire makers, help understand the conditions that these products are being used in to make better and more informed decisions. And I mean, the story ends very well. We have this thing called Freeway Service Patrol that put on a spare and she went to the dealership. But just thinking of ways that this can all create an ecosystem to better improve our roadways, but also help our automotive manufacturers make informed decisions to, again, better society and transportation.
Yeah, absolutely. I think that's a great use case that you called out. That with the power of the AWS ecosystem, of which IoT FleetWise plays a key part of, they would be able to collect this data in near real time before these incidents actually occur, and be able to predict and inform their customers that in these environmental conditions, your tire is, the health and the safety of your tire is going down. So take precautionary measures before the incidents even happen.
Yeah, absolutely. And Kyle, is everything okay? Is everyone safe?
Oh yeah. She's
Okay.
fine. She was more or less like, why did this have to happen on my way to work? And of
I
course,
feel
I'm
like we're
like,
focusing too much on the tech and not enough on your family right now.
no, she's very well, and the tire is going
Okay,
to get replaced just fine. And
I'm glad.
but yeah, and then fortunately that freeway service patrol, but also then thinking about these other services that your state may have to assist when someone has like a blown out tire. Could they have like a pub sub type of subscription to where they could see, a vehicle 2 miles down the road had a tire that blew out and it needs to be replaced. What's the condition
Yeah.
of their spare, or do they even have the spare in their vehicle? Ways to make it more interconnected, which is great.
Yeah.
Yeah. And Kyle's giving us like a whole lot of personal experience, personal scenarios. Bhushan, do you have any specific scenarios that maybe you can share with us about maybe customers you've worked with?
Yeah, so one of the really cool use cases, and I'm going to showcase in a demo today, is a problem that automotive customers can solve for battery range estimation of their electric vehicles. As we all know, electric vehicles are a much better, are more sustainable, in terms of reducing carbon emissions. However, the compared to ICE vehicles or internal combustion engine vehicles, the range is not up to that same bar. And so predicting the range of an electric vehicle accurately is a very common problem that can drive electrical. If we solve that problem, can drive EV adoption and accelerate it further.
And the range is how far the vehicle can drive on a single charge. Is that right?
That's correct. That's
Okay.
correct.
I feel like that's something we'd want to be very accurate with.
Exactly. Yeah, and I mean most automakers today use a deterministic model on the vehicle agent itself or on the edge itself. But there are ways where if you can collect all the parameters that affect the battery range, including environmental conditions like the road inclination or battery temperature, the vehicle speed, the curb weight of the vehicle, and you can build a model in the cloud, which is very customized to specific models of vehicles in specific locations, and then use that to to deploy on the vehicle a model to predict the battery range way more accurately. And so
So all
that's
based on temperature and like I'm guessing humidity because there's like wind
Tire
resistance,
pressure.
air pressure, tire pressure.
high
Yeah.
pressure.
Uh,
Yeah.
I can laugh
that's a
at it,
good one.
okay?
I mean, hey, I'm just glad your family's safe.
But
Also, like the battery weight and maybe even like the overall like load within the vehicle. And you mentioned we have a demo too. So is that directly related to what you just talked about?
Yes, that is.
I love demos.
Are you ready for us to bring your screen up?
Yep, I'm ready.
And
do it.
whoops. We both hit the button. It's my
It
button,
happens.
Aaron.
Awesome. Yeah, I'm super excited to showcase what we've been working on. And with GA, one of the cool features that we launched at GA was support for cloud formation. So you can obviously do everything that you can with Fleetwise using the APIs and the console. But now you can also define your entire vehicle model and all the resources that are required to collect data with a single CloudFormation template. And with the click of a button, you can start collecting data within a span of a few minutes, actually. So I'm going to go over the CloudFormation template and describe what resources we are looking at. So the first resource is the signal catalog. And a signal catalog is the superset of the data models of all the vehicles that an OEM or a tier one supplier might own. And it defines the signals, the actuators, the domains, and the relationships between those entities in a standard that we're in an open source standard called Vehicle Signal Specification, or VSS. So here's a more, it's an open source standard, and here's a more graphical representation of what a vehicle model looks like, right? And it's very easy and user-friendly to actually map it to actual domains within the vehicle. So for example, in order to define a sensor like speed, we know that that speed is within the chassis domain, and we can basically, oh sorry, in the transmission domain, my bad. And we can basically build this tree that that links the domain drive transmission to drivetrain and then back to speed. And then you can also define what type of that, what is the type of that sensor. It's a it's a unit 16. It is the units are kilometers per hour, and there are some constraints like minimum speed 0 kilometers per hour, max 300 kilometers per hour. And the advantage of doing this is, and representing the vehicle's data model in this way, is that you can now standardize all the data, regardless of whether it's in one format or the other on the actual vehicle, in this hierarchical domain architecture. And then you can use this to run queries like give me data for all the sensors within the transmission domain or within the battery domain of the vehicle. So that's what the signal catalog is.
And so you mentioned that this is kind of like a standard-based approach that's open source.
Yep, that is correct.
So there's like a likelihood where you can have automotive manufacturers making these different types of queries or parameters to then hand over to third-party manufacturers that want to do something with this data that they're generating, right? So it's creating this more friendly ecosystem instead of someone trying to adopt their own standards or create or reinvent the wheel, no pun intended. So this is the second time we've talked about open source technologies this show. What is this saying? Is open source the future?
Ooh, that's a good one. So I think open source might be the future. I mean, like even our own documentation is open source. So when we start distributing out links, if actually, hey, heads up, everyone, there will be links. Also a link to our survey. So keep an eye out for that. But Bhushan, you mentioned all these different sensors, and each sensor, I'm guessing, is sending a lot of traffic. It's sending a lot of data, and that data has to go somewhere. And because the cars are driving, is there any way that maybe these cars and IoT devices are connected to our edge network?
So today we supply, when we talk about open source, right? So there is an edge software which is running on the vehicles, and that's basically that the interface of the edge software understands, the interface that the Fleetwise service, the cloud component of Fleetwise, speaks. And so there is a communication between the edge and the cloud, and through which the cloud APIs and cloud service is able to send instructions to the edge software on the vehicle, ultimately to collect, to define what data to collect and at what frequency and in which conditions to collect that data.
That's really cool.
And the edge software is also open source, by the way. So you can go to this GitHub link, which I will be sharing later. You can go and run this edge software on an EC2 instance and start playing with it.
And so it sounds like you're able to deploy this with, CloudFormation, so it's reusable over and over. Now, do you have a way to show us what it looks like to query this data?
Yeah, let me just go over let me just create the model, and then I'll run a campaign. And then as soon as I run the campaign, you can start seeing the data in time stream. Cool. So I'll just do that.
Yeah.
Awesome. And so that's basically the vehicle model. And then you can also see that we can also define in CloudFormation, what is the how to collect the data on the vehicle itself. So as I mentioned, we decouple the high-level data model from the lower-level in-vehicle communication standards. And so this is the resource called Decoder Manifest, where you actually define those standards, those protocols. So in our example today, we're going to be running the data collection campaign on a vehicle which uses CAN, or Control Area Network Protocol. And so we basically define all the sensors like temperature, range, and all the parameters that the edge software will use to decode and transmit this data. And we've also defined some vehicles as part of this CloudFormation template. So let's just go ahead and deploy this template at this point.
So it's all done through a CloudFormation template. So infrastructure is code. So I'm guessing if someone were to make changes to the code, they can version control that somehow, and then also roll changes back if they decide that they want a previous version, or maybe like a different stack set as well. So all integrated directly within the CloudFormation product.
Yeah, absolutely. Yeah, that's the beauty of being an AWS service, that you get to use all the great ecosystem, the infrastructure as code ecosystem that AWS has developed in the automotive domain, which is pretty exciting and pretty new.
And on average, about how long does it take for the CloudFormation template to deploy that you've seen?
So this template, we'll see it get deployed within a matter of 20 to 30 seconds.
That's really awesome. So they can do it based on like some kind of cloud-based configuration deployment using CloudFormation, or something else. Maybe if they have a preferred other type of way of deploying their infrastructure. So infrastructure as code is super powerful. There's nothing different here.
Yeah, they can use CloudFormation. They can also use the console, and they can also use our API and the CLI to create their resources.
That's awesome. And while we're waiting for this to deploy, I do want to mention for everyone here who's watching, if you're brand new, this is AWS On Air. My name is Aaron Hunter. We have Kyle Dickinson. We have Stephanie here helping us to translate messages out to each one of you. And we also have a survey. So keep in mind, there's something out there. There's a link in the chat. We want to hear from you. So take 5 minutes, complete the survey, and the first 50 respondents to that survey will get a $10 AWS credit.
You sure will.
Let's go to the AWS Fleetwise Console to actually see the resources that we just created. You can see the signal catalog. This is the vehicle model, and you can see the battery branch, or the battery domain of the vehicle model now has four signals: net capacity, range, state of charge, temperature. Now let's create a data collection campaign that will allow us to define the parameters.
Yeah, and we are coming up on time. If you're able to show us this real quick, we'd love to see it.
Yeah, absolutely. See campaign as EV campaign.
I guess this will be an example of, if you have to get through it as fast as possible, how fast can you actually do it?
Absolutely, let's do it. And select a time-based campaign, and every 10 seconds the data will be ingested. Let's select two signals, the state of charge and temperature, and create the campaign.
I've always wondered, if you put an electric vehicle into a freezer, if it would charge the battery like you used to do with AA's and stuff. You never had to do that? No? Maybe it's just something that I was told as a kid to make me feel better.
Dating yourself. Dating yourself.
Awesome. So the campaign is ready, and now let's see the data in time stream.
All right, and TimeStream, this is one of our database offerings that really allows us to be able to take some time-sensitive data. So, for example, the IoT sensor information and ingest it directly into a readable format. Is that right?
That is correct.
Oh,
And thanks,
Okay.
yeah. And here you can see I'm collecting data from the last 5 minutes.
oh wow.
And in the campaign that I just collected the data from is available in TimeStream in near real time.
That's
Awesome.
really impressive and really powerful. We can do a whole lot of stuff with this. So now that we have a better understanding of IoT FleetWise and sensor data for vehicles, where can our learners or viewers go to learn more in, let's say, 10 seconds?
Yeah, so they can go to they can go to the GitHub page for the Edge software and go through a quick start demo. They can also go to the IoT FleetWise getting started page on AWS.
Cool. Awesome. Bhushan, thank you so much for being here. We really do appreciate it. And take care for, actually, well, congrats on your launch. Congrats on going GA. And
Yeah.
for
Thank you so
everyone else
much.
who's watching, stay tuned. We have someone else coming up right next.